Hi, everybody, and welcome to week 3 of online learning. I hope you're doing well. You had a nice weekend. You were able to rest up a little bit. So, this week we're starting with something new. This week we are starting with solving systems of equations by graphing. I'm going to tell you what that means in a minute, but you know how we're going to start every week. We start every week with a comic. So, here we go. I drew the two parts of online learning, two feelings, how you may be feeling. And it's pretty punny, and I'm going to warn you I may embarrass myself, but I'm okay with that. So, first feeling pretty overwhelmed. It's a lot of work to do, and it's feeling like the work is too much to bear. Ha 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 ha, you get it? I know, pretty painful. I think that one was painful. Wait for this one. Or you're feeling like this guy. You know, you're just straight chilling. You're doing great, and you're hanging in there. You get it? He's hanging in there. I know. Those are pretty bad jokes. I can promise you that next week will probably be even worse. With that said, we're going to get into the math. Here we go. So, solving systems of equations by graphing. So, before we do this, we need to figure out what is this? What is a system of equation? Well, what a system of equation is you're given two equations, and what you do when you solve for them is you figure out for which value of x and for which value of y will make both of these equations be true. So the x and y we find, when we plug them back into our equation, both of these equations have to be true. So, how this will work by graphing is when we graph both of these lines, the point where these two lines meet will be our answer. Our x coordinate will be our x value, and our y coordinate will be our y value. Let's do an example so we can see what this looks like. So, let's grab a nice color. We're going to go blue. So, the first thing that we're going to need to do is we're going to need to graph our first equation. Our first equation is y equals 2x plus 2. So we know how to do this, right? We know that the first thing we always do is we plot the y-intercept. Our y-intercept is 2, right? Because this is in y equals mx plus b form. And we know that the b, or the 2 in this case, is our y-intercept. So we're going to graph that. And when we graph that, we're going to get our y-intercept to be right here at the 2, okay? Then we know that our m value, or our 2 in this first one, is our slope. And we know that slope is rise over run. So we're going to go up 1, 2, and over 1. We're going to go up 1, 2, and over 1. 1, 2, and over 1. 1, 2, over 1. And we're going to do that the other way too. We're going to go, but when we go the other way, we're going to go down 2. So down 2 and over 1. 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 So it's super important that our lines are extremely accurate. So what I recommend doing these is either we need to draw a perfectly straight line, or what I like to do, I like to make a bunch of dots so that we can see which dot is hitting both lines. So what we're going to do now is we need to graph our next line. Our next line is y equals x minus 1. So, just like the last one, we're going to start with our y-intercept, and that's going to be negative 1, right? And that's going to fall right there. I'm going to show this is green, and this is red. So, next thing that we need to do is we need to find our slope, right? And we know that if there's no number in front of our x, then the number that's actually in front of it, that's not right there, but is there, is 1, right? Because 1 times x is x. So we're going to go up 1 over 1, up 1 over 1. But wait, we want to know where these lines are going to cross. It doesn't look like as we go up, they're ever going to cross. So what we're going to need to do is we're going to need to go down. So we're going to go down 1 over 1, down 1 over 1, and down 1 over 1, and then boom, look what we have. We found our point where it exists on both lines, and it's right there. So that point is going to be our answer. So we need to pick out the coordinates of it. So our coordinates are x is -1, -2, -3, and our y is -4. So we're going to go up here, and we're going to write our answers down. We're going to say that x equals -3, and y equals -4. However, we're not done. The last thing that we need to do is we need to check our work. So we need to plug these values in to make sure they're true. So we're going to plug in -4 for y, and we're going to get -4 is equal to, I'm going to zoom out a little bit, 2x, and we know that x is -3 plus 2, right? That's what happens when we plug in our x and y, our -3 and -4, into this top equation. And now what we have to do is we need to make sure this is true. We're going to get -4 is equal to -6 plus 2, and -6 plus 2 is -4. -4 equals -4. So the first one works. So now we need to just make sure the next one does. So we're going to plug in y as -4, and we're going to get -4 is equal to -3 minus 1, and we know that -3 minus 1 is -4. We're going to get -4 is equal to -4, and we are good. So we're done with example 1. We found that the values that make this equation true, both these equations true, is when x equals -3 and y equals -4. You just solved your first systems of equations problem. Alright, here we go. This one's a little different. I want you to take a look and see why it's a little different. I'm guessing what you noticed is that we don't have y by itself on one side. So for these ones, what we're going to have to do is we're going to have to do that as our first step. We need to get y by itself, okay, for both these equations so we can graph. So my first step for this top one is I'm going to minus 3x to both sides. And when we do that, we are going to get -2y is equal to -3x plus 4 then we need to get y by itself, so we need to divide both sides by -2. When we do that, we are going to get one of our new equations. We're going to get that y equals -3 over -2. We know that a negative over negative is a positive, so 3 over 2x plus 2. Oh, but what kind of 2? It's a negative, right? Because 4 divided by -2 is -2. So in blue, we have one of our new equations. So what we need to do with the other one is we do the same thing, right? We need to solve it to get y by itself. So the first thing that we're going to do is we're going to subtract 2x to both sides. And we're going to get -y is equal to -2x plus 1. Then we know we can't have a -y, so we're going to have to divide everything by -1. We're going to get y equals, I'm going to do this in blue just so we can see both of our new equations. We're going to get y equals 2x minus 1. Now, what we need to do with both of these equations is we need to graph them. So we have y equals 3 over 2x minus 2. So our first step is we're going to graph our y-intercept. And we know that our y-intercept is -2. And we know that our slope is 3 over 2, right? 3 over 2x. So we're going to go up 3, and over 2. We're going to do this so we get a bunch of points. Oh, I went up 4. Up 3 over 2. Up 3 over 2. Up 3 over 2. And we're going to do the same thing in the other direction. We're going to go down 3 and over 2. Down 3 and over 2. So we have our line. Next thing that we need to do is graph our next line. And that was y equals 2x minus 1. So we're going to graph that. We're going to graph our y-intercept. We know our y-intercept was negative 1. Then we're going to do what our slope tells us to do. Our slope says that we need to go up 2 and over 1, right? That was our rise. So that's exactly what we're going to do. We're going to go up 2 and over 1. 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 We're going to do the same thing on the other side, except for now we're going to go down 2 and over 1. Down 2 over 1. And then look, we have our answer. Boom. And we can see that our x value here is negative 2, right? Because at negative 2 is where our point is. That's our x for it. And then our y is going to be negative 5. And we can see that because it's right here, and it's our negative 5. And the last thing that we need to do is we need to plug these values back into our original equation to make sure we're right. So we think that x equals negative 2 and y equals negative 5. So let's plug them back in. Let's grab a different color. We'll go white. So we're going to have 3 times negative 2 minus 2 times negative 5 is equal to 4. How I got this was I am just plugging in x and y into this equation, into one of our original equations to make sure it's true, right? I plugged in negative 2 for x, and I plugged in negative 5 for y. And then from here, what we need to do is we need to solve. We're going to get negative 6 plus 10 is equal to 4. Negative 6 plus 10 is 4. 4 equals 4. We know that the top one works. The last thing that we need to do is we need to check the bottom one. And when we do that, we're going to get 2 times negative 2 minus negative 5 is equal to 1. And then 2 times negative 2 is negative 4 minus negative 5 minus 1. And we know that when we subtract a negative, it really becomes a plus. So it's going to be 1 is equal to 1, and it works. So this is what solving systems of equations by graphing looks like. Give it a try. Please, please, please ask questions. I don't think enough of you are using that. Come into my office hours, send me an email, and we can find a time to work on some problems if you need it. With that being said, have a great week, and I'll talk to you all soon. Bye.